Good afternoon, everyone. So, shall we wait for 2-3 minutes for others to join?
Sir, meanwhile, can you explain one activity question?
Yes, sure. Can you just
2.11 sixth one.
okay? Just a minute. I'll share my screen. 1 minute.
2.11 sixth one.
Yesterday, what we have discussed yesterday?
We have discussed the maximum, sir. Maximum is fine, but minimum I'm not understand.
Okay. So, minimum of x1, x2 to xn, right? Okay. What we can do? I understand. So, similar problem is there in this today's solve with us session. Okay. So we'll go through that questions first, and if later on if you don't find it the similar one, then or if you have if you find any difficulty, then we'll solve it. Will that be
But
okay?
can you explain how to approach minimum type of problems?
So you see, Z2 is what? Minimum of x1, x2 to xn, correct? Now x1, x2 and xn are what? IID binomial with the n equals to 6 and p equals to 1 by 2, right? The probability of success. So each x1 is what? So each week, what is the range for this x1, x2, and xn individually?
0 to 6.
0 to 6, correct? So if it is 0 to 6, and what we have asked here, f z2 of 2 means what? What is the meaning of this?
Should be less than or equal to 2.
Yeah, this is CDF, right? CDF of
summation of 0, 1, and 2, sir.
Correct. 0, 1, and 2. So what does that mean? That means it should be minimum of x1, x2, xn, right? So it means like either of x1 or x2 or x3 up to xn, the value, the minimum value taken by one of them will be what? Less than 2.
Equal
correct?
to.
Less than or equal to 2, correct?
Correct.
Yeah.
So that means 1 minus, can I write 1 minus minimum
Sir,
of maximum
sir,
of?
can you write that on whiteboard, please?
Yes, sir. Can you please write, sir? Yeah.
Okay, fine. Yeah. It's visible right here?
Yes, sir.
Okay. So what we have given here, x1, x2, x10, all are IID binomial 6, 1 by 2, right? Okay. And what we have asked is Z2 is a variable which is minimum of what? x1, x2 to x10. So we know what is the range of each xi here. It is from 0
to
1
6.
2 to 6. This is okay?
Yeah.
And what we have to find is fz2 of 2. This means what? Probability that z2 takes
Z2
value
less than 2. Yeah.
Right. So I can write probability that z2 is what? Minimum of
x10.
So the minimum value of this, it should be less than or equal to 2. Right?
Yeah.
Now what does this interpret? Can I write like this? So it is same as that of probability 1 minus probability of max of.
Yeah, sir. This step only I'm confused with. Why are we writing like this?
So suppose this is your time. This is your number line. Okay, it starts from 0, 1, 2, 3, 4, 5, and until let's say what? I'll say 10. Okay, here in this case it's 6 only, right?
Yeah.
Sorry. So
it's supposed to be minimum of x1, x2, x10 greater than 2, right?
Okay, I will tell you just a minute. So this x1, don't consider about this all the multiple random variables. If I wanted to say, suppose for only x1 is less than or equal to 2. What does that mean?
0, 1, 2.
So that means this portion, right?
Yeah.
So what I can write here, 1 minus this portion. 1 minus this portion also is same as that of this red one, right?
Yes.
Yes.
So I can write x1 greater than 2. Correct?
Yeah.
It's fine. Now similarly, if I say minimum of x1 x2 to x10 is less than or 2, what does this mean? Okay, what is this minimum of x1 x2 of x2 x10 by less than 2 is what does that mean? What is the understanding from that sentence?
One of the random variable has to be less than or equal to 2.
One of the random variables has to be less than or equal
Less than equal to 2, sir.
to, and others can be greater than 2, right?
Correct.
Or
Yes,
Correct.
yes.
Right.
So all of them can be equal to 2, or all of them can be equal
Yeah.
to 2.
So that means the one of the random variable should be less than or equal to 2, and all can be this side, right?
Right,
Greater than, then only this is possible, right? So
right.
so how I can write in the other way?
why only one needs to be less than 2? Like multiple can be less than 2, right?
No, yeah, multiple can be. So there will be 2, 3 cases
At least, I said at least.
at least. So that's
Yeah,
why.
yeah, at least.
At least one of the variables should be less than or equal to 2. Then only this case will happen, right? And others.
So it can be written as 1 minus none of them are less than 2.
So what does that mean? So max of what is this meaning? What is the meaning of this? Max of x1, x2 to x10 greater than or equal to 2?
Everything is 2 or strictly less.
Everything should be
Greater than equal to 2.
2 or less than 2.
no one. See, max of this means at least one of the random variable.
Correct, at least one of them should be
Random variable should be
greater than equal to 2,
2.
or all of them should be equal to 2.
Correct?
Sir, but it should be like only equal to greater than
Sir,
2, sir. Why we are using equal to condition here also?
I think 1 minute. Yeah, 1 minute. Maybe what we have to do is, so minimum of x1, x2 to x10, it should be less than or equal to 10. I can write in.
Excuse me, sir. Shouldn't that be min of x1, x2 greater than equal to 2?
This one? What you're saying? Here.
Yeah, min.
Min of x1, x2 to x10 is greater than or equal to 2. Yeah, I think this should be minimum. Right?
Because now the minimum value has to be greater than equal to 2.
I did max right here. Now if
why
one
greater than or equal to 2 again should be
Yeah,
greater
it
than 2, right?
Yeah, it shouldn't be equal to 2, right?
Yeah, correct. It should be greater than.
correct, right? I can write in this way, right? Minimum of.
Then the PMF will be counted from
Max
3,
will be
sir.
there, no, sir. When I'm writing 1 minus 3, then it should be max there.
No.
No. If it is max, then what will happen? One of the random variable
Is
like
greater than equal to 2.
greater than 2. Correct.
Greater than or equal to 2.
No. See, first.
Then the PMF is starting from 3, sir. I mean to say 2.1, 2.2 kind of thing also will be included in the
Binomial, this is discrete one, right?
right, sir.
So it won't take 2.1 or something. It will take 2, 3, 4, 5, 6. These values only it will take. Now probability that minimum of x1, x2 to x10 less than or equal to 2 means what? One of the random variable should have value less than 2 and others can have equal to or greater than 2. What I can write in another way is one of the random variables can have so say it will be the same probability as that of one of the random variables can have value. It can take value greater than or equal to 2, right? Now it's less than or 2 is the minimum one, right? So what we are doing, we are calculating this probability for this, right?
But for this, multiple cases are possible now. For minimum should be less than or equal to 2.
Yeah, that will a lot of cases will be there. That is true. Multiple cases.
Then why are we considering only this one?
Which one?
Like only 1 minus p of.
So here also we are considering multiple cases, right?
Sir,
Okay, sir. Can you explain after that step once again, like clearly?
Can I say something?
Ah.
So I think yesterday also we got stuck close to this point only. We were doing the derivation. Then you said, okay, tomorrow at the beginning of the class, I will do the derivation. Then things will be more clear.
Yeah.
So
I know that.
So if you derive that formula, so things will be clear, because every day we are getting stuck at this point only. For last 2 days, we are getting stuck.
Okay, so I will show, I will tell you first of all, if you are getting that same problem, right? First of
Yes.
all, okay, we'll see some of the things, and it might be clear now. Let's say new node.
I think in lecture 2.11, professor has derived this formula. So we are getting stuck there somewhere.
Yeah, that formula, right? That is correct only.
For mean and max, we have derived.
Mm-hmm.
We are getting stuck
So,
somewhere.
That formula is only for geometry. This is different, right?
but
No,
it will
but
be
I think-
applicable to everything actually. See,
I think once you derive, then things will be more clear. You know?
so tell me, what is this meaning? Xy is minimum of xy is greater than some value k. What does this mean? So how can we write this? Minimum between x and y is greater than or equal to k.
X
One
is
number
equal to
is-
k and y less greater than k. Just a second.
Both
Uh,
both x and y are greater than
three conditions, sir.
Hmm?
There
Sir,
will
but
be
when
three
I'm using,
conditions, sir.
sir, when I'm
Either
using the
x
function mean,
and
sir,
y
then
equal
why
to
I'm
k.
writing greater than equal to k? It should not be less than equal to k.
No,
that's
no,
the
no.
CDF. Right?
I'm taking this now. What I'm taking is I'm taking all the general conditions. All four. There are 4 general conditions. I'm taking for 2 minimum and 2 maximum. Like for 2 conditions for minimum and 2 conditions for maximum. If you understand this right, you will be able to solve any problem. That's what I wanted to do.
Yeah,
So see,
great.
okay, is this correct? What I have written here, minimum of xy, if it is greater than or equal to k, what does this mean? Is this
Just say
correct?
when x is greater than equal to k and y must be greater than equal to k.
This is correct?
Yes, sir.
yes, sir.
Everybody understood this?
Yes, sir.
Right. Now tell me about this. Minimum of x comma y is less than or equal to k. Can I write like this? X is less than or k and and y is less than or equal to k.
Yeah.
Can we write this?
No, we can't write like this.
We can't write. Why?
We can't write like this.
Why?
Because either of the minimum.
Because one of them can be greater than k, but still minimum will be less than k, right?
Sir,
like one of them should be
and
greater than k.
So in this case, what we have to write? Tell me. We can have 3 conditions right now.
yes, sir.
So it can be x equals to k, y equals to k, right? Plus, or it can be like x is less than or equal to k and
Y greater than.
y is strictly greater than k, right?
X is equal to k and y greater than k. Right?
Yeah.
This is right.
Yes,
But
sir.
we can't write like this, right? So you understand what is the difference here? So this k is some value, right? Some k is some value. If this is less than the minimum of x and y, that means what? Because k will always be this side of x and y. Whether minimum of xy is here, k will always be this side. So we can safely write that if x is greater than or equal to k and y should be greater than or equal to k. If these 2 conditions will satisfy, then this is true, right? But for this case, it is not possible, right?
Yeah.
Correct. Now tell me for this max of x comma y greater than or equal to k. How can I write this? Can I write like this way or like this way?
Second way.
Everyone?
The first one, sir. X greater than equal to k and y greater than equal to k.
Okay.
No,
So
no.
for-
Even if one of them is greater than k, it will be true. Even if one of them is greater than k, it will be true, right?
One of them is greater than, yeah. Suppose my
That
k
is also one of the case. But if both are also greater than k, then also it will be true.
then how can I write? Can I write like this?
Yeah.
Less than
Less than k and y greater than equal to k.
Right?
Yeah.
Is okay?
Yes, sir.
So if both of them are greater than k, then what will happen? Then also the condition will be satisfied.
So this is written. Okay. What you're
Yeah,
saying?
If both of
that's
them are
also
greater, if both of them are greater than k, my x and y are greater than k.
Ah,
So of course one of them will be my max, right?
correct.
And by default that will be greater than k. So why we can't write that condition also?
Yeah, we can write that also, right?
yeah, sir, that is true.
Yeah, one more condition. Yeah, plus x is greater
Greater
than.
than k.
So yeah, this condition will also satisfy, right? Because whatever maximum of between x and y is there.
Yeah,
So
that
for
is-
minimum also both can be less than k, right? We should add one more condition there also.
For minimum,
Yeah,
minimum
about this.
between x and y k, if k is that greater than x and y, right?
No, sir, in the second one we wrote only 3. We can add one more, right?
Mm-hmm.
X less than k and y less than k.
Isn't it included in any of the one of these conditions for both the things? See, x is equals to k and y is equals to k, right? So if that is there, we can find the probability for that. If x is less than or equal to k and y is greater than k, that means k is greater than x and okay and okay. Can you write that? Is it
yes,
possible?
yes, sir. What is saying that is correct, sir. For min x comma y,
Hmm.
if both of them are less than k, then also
Hmm.
my condition is satisfied. Na? So one in the second case of min function, one more condition will be added. Yes, this one. Y is less than k, right?
So I can say that less than or equal to is fine, right? Okay.
We can plug that.
Yeah, so okay, what I will do is we can add it here, right?
Yeah.
So here also the first one will be greater than equal to k. Yes.
We can
Yes.
do this, right?
Correct.
This same things are there, right? Why to
Yes.
find the probability
Yes.
separately for this? So 3 will be there. Okay, one more. Tell me about this.
No, x less than equal k and y less than equal k.
So it will be x less than or equal to k, and so both the conditions should get satisfied, right? Then only we can have this condition to be true. So how many of people understand, like don't understand this thing? What you have written?
But how to apply this into the problem which
Yeah, that's what.
which I asked?
Yes,
Yeah.
up to this it is clear, sir.
This is
Yeah,
okay.
this is
Until
clear.
this is okay. Now what is our problem? Z2 is minimum of this, and we have to find the CDF of CD. And what is the so we have to, okay, let's see, we have to find FZ of 2. So what does this mean? Probability that Z2 should be greater than should be less than or
Less than equal to.
right? This is what probability that minimum between x1, x2 to x10 less than or equal to 2.
Yeah.
Is it true? It's true. Correct?
Yes, yes.
So by
Yes, sir.
any one of the formula, which one we can use here?
Second one.
Second one. But there are 10 variables here.
10 variables. Now what
It is
what
like-
huh?
Nothing.
What other case can you consider for this?
First, we can find for x1. Then if you multiply 10 times, because they
Yeah.
are identically independent variables, so we can directly multiply.
Okay, that is one of the thing, right? So you can go
Yeah.
by this way, like this way. But again, see, how can you write only for x1, right? Here,
Do 1 minus the first equation.
1 minus what?
The first one where it is x is greater than.
So this can I write like this? X1, x2 to x10. It should be. This is okay, right?
Should
Yeah,
there be
why
an
this-
equal to sign?
Strictly greater
Why this is greater than or equal to 2?
It should be strictly greater
No,
than.
only
two.
greater than it should be, sir. I solved doing only greater than 2. I got the answer for that.
Because okay, so this is minimum is less than or equal to 2. So okay. So any condition it will, is this like if whatever I have written here, is it like violating the like, is it not the correct thing? Why?
No,
Like,
it can't be equal to 2. It should be greater than 2.
But it will overlap now if you like write this.
one
It should be
case will be
greater
there.
than 2, sir. Yeah, yeah.
Okay.
Now
Yeah.
it's
Should
okay.
be greater than 2.
Okay. Okay. Now, can you find the answer for this?
Yeah. 21 by 2 raised to 5.
Yeah, no, no, that is the last one.
Oh,
So
sorry,
just,
sir.
Let us continue with the derivation, sir.
Okay, okay.
step by step, you know.
Yes.
So this is okay. This is agreed, right? Now this step is agreed, correct?
Yeah, yeah.
Okay. Now tell me now how can I write the probability for this?
So we have to find probability from 3 to 10, sir.
So how can you?
And add everything.
I think we can simply write everything is greater than 2 and proceed.
Yeah, everything should be greater than 2.
Yeah.
And then to the power of 10.
To the power of 10. So what is for x1? So
It's a summation from 3, 4, 5, 6.
ID binomial 6, 1, 2, right? So
6 into
tell me.
It's a summation from 3 to 6.
Yeah, 3 to 6.
Probability of x is equal to 3 plus x is equal to 4 plus
3, 4, 5, 6. No.
6. Yes.
3. So can anyone find this? Like I don't.
42. So
Huh? How much?
it comes to 42 by 2.
42 by 2 raised to 6. So it is 21 by 2 raised to 5.
Yeah, 21 by 2 raised to 5. Whole power 10, right?
Whole power 10.
21. So yeah, 21 divided by
2 to the power 5.
because of and to the power
10.
10.
So that should be the answer, right?
This 42, how did it come?
Okay,
42?
okay. I'll tell you. So see, you have to find the probability. So this thing is there. So one random variable x1. Okay, x1 greater than 2. What should be the probability? It should be x1 equals to 3, 4, 5, and 6, right?
Yes.
For 3, what should be? So everything is ID binomial. So it should be 6c3, right? What
by 2 raised to 3.
After the
6.
power 3
We can
into,
directly write 1 by 2 to the power 6.
So this is 1 by 2 to the power 6, right?
The step. Sir, can you please write the step?
Yeah, I'm writing it. Okay. So x1 is this values, right? 3, 4, 5, and 6, right?
Yeah.
Correct? So for
Yes.
x1 equals to 3, and this is a binomial. So for binomial distribution, how can I write x1 equals to 3? It should be 6c3,
Yes.
right? P to the power 3. So what is p here? It's 1 by 2.
To the power 3.
And 1 minus 1
1 by
minus
2
power,
n minus k.
Yeah,
Okay,
so
6 minus 3. 6 minus 3 is
so
3.
so this is what? This is
This
1
is
by
for
2 to the
3.
power 6
This
only,
is for
right?
x1 equal to 3.
No, but this is what? So I can write like this, right?
Right.
So for 4, it should be 6c4,
Correct.
1 by 2 to the power 6, plus 5, 6c5, 1 by 2 to the power 6, plus 6c6, 1 by 2 to the power 6, right? Now,
Yeah.
what is the 63? Can you tell me the values? So 1 by 2 to the power 6, I can take common, first of all, into, so what is 63?
20, sir. 20.
25, right?
20, sir. 20.
Yeah, 5 into 4, yeah. It's 20. Plus
15.
64 is 6 into 5.
15, sir.
By 2. Yeah. 15.
15. 6.
6, correct?
Plus 1.
So 20 plus 15 is 35. Plus 7, 42. So this is 42 into 1 upon 2 to the power 6. So 2 to the power 6 means I can write 2 into 2 to the power 5. So this 2 into 4 is 21. So it is 21 divided by 2 to the power 2 to the power 5. Now this is for, so what this probability is for x1 is greater than 2, right? Only for what? One random variable. And how many random variables we are having? And all are ID. So we are having 10 random variables. So multiplying all the probabilities for all the 10 random variables, it will be 21 divided by 2 to the power 5 raised to 10. Correct?
Yes.
Sir, just I will take 1 more minute, sir. This regarding
Yeah.
this derivation, sir. Can we come to second and third last line? Like we started with fz2, in bracket 2, right? Yeah, second and third line, last line. In the second line, we are talking P, probability of min, x1, x2, x10 less than equal to 2, right? So why we were not able to proceed further? What prompted us to change it into 1 minus P? This line I'm stuck, sir. After that,
so how no, we
except this,
can
everything
write,
is clear, sir.
okay,
Except this,
what
everything is clear.
correct. So see, you said here minimum of xy is less than or equal to k. The probability we have to write like this, right?
Correct.
So we 1, 2, and 3 terms will be there. Okay.
Right.
So here we have only 2 random variables.
Right.
So how can you find probability for 10 random variables like this way? So how can I have to write? So it will be x1 is less than or equal to k, then x2 is less than or equal to k, then x3 is less than or equal to k, like that. X10 is less than or equal to k. This is one, right?
So those will be multiplied or those will be added, sir, for 10 random variables?
These will be multiplied, no?
Okay, independent trace. Okay.
Right. And then again, these are all joint densities, right?
Right, yes, sir.
So again, for this, so you have to write like how many equations you'll write? Lot of, right? Because here we had only 2, so we had 3 terms. But for 10, how many you have to write?
Yes.
So this is very difficult, right?
Okay.
So we did.
So we did 1 minus probability of min greater than 2, right? So why
for better than 2? It's only this thing.
Sir, one small doubt. In the case of maximum,
sir, continuing with this, sir. Like say for example, if in place of 10 random variable, if it could have been 1 random variable, right? Hello.
I'm listening.
Yeah. It could have been 1 random variable and it is less than equal to 2. So it means probability of 0, probability of 1 and 2. We have to add these 3 probabilities, right?
Correct.
Okay, thank you.
Okay.
Sir, in case of maximum, why are we not doing this 1 minus method? Only in the case of minimum we do this. Why?
No, it depends on problems, right? You can do that also. See, if suppose you got like something is there. Suppose if so z1 is some max function, okay, and if I wanted to say if z1 is and there are same problem you take and you wanted to say for if z1 is greater than 2, how can you write? And z1 is max of x1, x2 to x10.
But here itself, instead of doing for 3, 4, 5, and 6, we can simply write for 0, 1, and 2 and solve. Now, why did we go to the trouble of 1 minus p min of all this?
Because this case I told you, right? This is not the directly 0, 1, 2 only, because you have to consider all these things you see here.
Okay.
So this joint densities, calculating this is very troublesome, right? It's very difficult. How many times you will add and do the calculations, right?
Yeah, I got it, sir.
For this, it's very easy, right?
Yeah.
Okay.
Yeah, it's clear now. Thank you.
Shall we go to our session?
Yeah. Thank you.
Huh?
Yes,
Okay.
sir.
And all the questions today, right? It will be on the similar line. So I don't think it will take like for you guys. It will be like practice to you. It will be like what I feel is you will get clear idea of minimum and maximum functions today.
Sir, join PD password have you created?
Yeah. I'm doing that. Right. Just a minute. Okay, this one. So please join in joinpd.com. The password is like WNSQHN. So 21 students have joined. Others, you guys are joining, right? Because I'm seeing 60 participants here, so at least 58 should be joining. Okay, 30 have joined, so I'm starting a class. So we have 7 questions today. So if it is okay, you can just like do some initial question somewhat in a faster rate, so that we can finish all the 7 questions today. Okay. Okay. So this is our first question. So let x and y be two independent discrete random variables with CDFs fx and fy respectively. Define another random variable z as minimum of x comma y, and what will be the correct options in between all these 4. So we have already discussed this today, right? So can you quickly find this answer? So this is MSQ. Okay, you have to find more than one options might be correct.
Answers.
Okay. So 35 students have joined this joinpd.com. Others, please join the joinpd.com. The code is here on top right side, WNSQHN.
The answer option is not coming, sir. We have to write answer. Hello. Hello. Sir, am I audible?
But I don't think he's here.
Thank you. I thought I have lost connection.
Is it completed? Okay. Okay. So I think yeah, a lot of people have given the correct answer. Somebody says A, B, C, B, D. So there are actually two answers correct, A and C. So why B and D is correct?
Incorrect, no, sir.
So for getting minimum one, as you explained in the previous slide,
Yeah.
you wrote that minimum of
X and Y.
Can you please go back? Can you please go back to your screen, please? The explanation page, please.
Right. We have already written, right? Z is equals to C.
Sir, yes. Here you have also written a P of minimum of x1, x2 up to xn less than equal to z. It means that for the minimum values less than equal to that particular variable, and that is also equal to 1 minus P of those random variables greater than.
So
that
this
is
is
the
given, right? Okay, Z is minimum of X comma Y. So I can, if I wanted to find PDF of this, right? Right?
Yes, sir.
So how can I write? Probability that Z is less than or equal to
X.
Right. And what is Z?
Also,
what is Z? It's minimum of X comma Y. It should be less than or equal to Z. So this thing, how can I write?
Like 1 minus P of X.
This, right? 1 minus?
Yeah. P of X less than Z and also
greater than
X2.
Z.
Yes, yes. That is 1 minus P of X greater than Z, A, and Y also greater than Z.
So option A will be correct, right? Similarly, this is a joint PDF, right? Probability that X greater than Z and Y.
That you have split it into two components.
Right?
P of
Probability
X
X greater than Z into probability that Y is greater than Z. Right. So A and C, B will be the correct options, right? Correct?
But sir, even the first sentence also makes looks similar with the B option, right? Isn't it?
So probability that X is less than equal to Z and Y is less than equal to Z, right?
Could you please show the screen and this B option and that option? Could you please write on the same page so that we can differentiate?
Yeah. Okay, not this one, huh? The other one.
Yes. So here also you have written a Z.
This is the line, right? So this is three things, right? Isn't it? Okay, maybe I'll.
If a combination of these three terms are given, then that can be the right option, right?
Correct. Otherwise, no, right?
Yes,
you are understanding this point?
Yes.
If you are able to see, okay, I'm trying to. Okay. Now you see. So this B option won't be correct, right?
So fifth line where you have written FZ2, sorry, FZZ is up to that.
This one.
Where is now your cursor is now that line. I believe that line is similar to the option B. Like, is it? Or am I wrong? Or could you please explain?
This line is not the same as that of this, right? Because I have written Z2 is less than or equal to 2. So this will interpret into this minimum of X1.
So
X2.
instead of Z, I can write no Z. Z is the minimum of X and Y. So I just can also interpret in that way, right? I just put that Z value in terms of X, Y, and that will be less than equal to 2, the way you have written. So do you mean that is not correct?
It won't be correct, right? Okay, don't consider this thing. Okay, leave now this one. Do you understand these 2 points?
That is clear. But actually, I was just
this is same.
Yes,
yeah.
Right. This and this, the second one is same actually. This is not different one. This is only written here like this, but actual interpretation will be like this, right? So there should be 3 terms here. Only one joint density is there, so it's not correct. Okay.
Okay.
Okay. So shall we go to the next question?
Sir, in the option A and C, the equal to condition is not there at all.
What happened? It's same, right?
Same, we had solved the previous sum, right?
Same problem.
In this we had discussed it should not be equal to, it should be only greater than.
Correct. So shall we go to the next question?
Yes.
Yes,
So
sir.
take 5 minutes here. We'll discuss the solution.
Sir, just one clarification in this question.
Yes.
K cannot take 0, right? Like value of K is given 1, 2, 3, 4, 5, 6. So K cannot take 0, right?
Yeah. Because this is a PMF, right? And K starts from 1 to 6.
Okay, that's fine.
So
Thank you, sir.
you have to add like x plus y, and that x plus y value should be equal to 3.
Okay, got it, sir. Thank you.
Okay. Okay. 2 responses. Okay. Okay. Option A, 3 people. Option B, 18. Option C, 0. Okay. Option D, 1. Okay, fine. So shall we wait for 2 more minutes? You guys, you understand the problem, right? So we have the joint, so we have the PMFs for x and y, which is 1 by 6 for k equals to 1, 2, 3, 4, 5, 6. So it is, you can definitely see that these two are the discrete random variables, right, with this PMF. And z is equals to x plus y, right? And we have to find the value of fz of 3. Okay. So how can you get like z equals to 3 if this is
Sir,
the PMF?
in these questions,
1 + 2 and 2
I'm not
+ 1.
understanding.
Okay.
Sir, okay, in these questions, sir, how do we get x and y? Like z is equal to x plus y.
So we have two random variables x and y, right? What is the range for x and y?
1,
1 to
1 and 2.
So range for x and y is what? Some noise is there.
2, 3, 4, 5, 6.
Correct?
Yes, sir.
This is right? Everyone is okay with this range? Okay. So z is what? Z is x plus y. Sorry. X plus y. So what can be a range for z? Can you tell me? Range of z. I can denote it by tz. What should be range?
2 to 12.
2 plus 1.
2 to
1
12.
plus 2.
Is it correct?
Yes.
Yes, sir.
Everyone understood this? If you have doubt, see. If you have doubt, tell me here itself, because see, these steps are very important. If you understand this, then you will be able to solve any problem. If you don't understand this, it's very difficult to you to find the answers. So how that range of z is 2, 3, 4 to 12 is because z is
Sir,
a
z is equal to 3, right? Z will be 3.
x plus
So
y.
1 x value 1, 2, and 2, 1, right?
Correct. So if I wanted z equal to 3, there are how many cases are there? X will take 2 and y will take 1, or
x1, y2.
Or x1, y2. These only two possibilities are there, right? To get z equals to 3.
So, but the range of z, how did you write that?
So range of z means whatever the values taken by z, right? So z is equals to x plus y. So when x equals to 1 and y equals to 1, z equals to 2. When x equals to 1, y equals to 2, right? Like until what? X
but z is equal to 3. Okay. We should not the range. We will take x and y value and correspondingly whatever.
Right, no? So maximum will be 6 plus 6, 12. Minimum will be 1 plus 1, 2, right? And whatever values in between. Okay.
But the question says that x and y are equal. So are we not supposed to take both same values as x only? X and y same?
It's just that the range of both are same, right?
Range is same only, right? What is equal means? The probability PMF is same, right? The probability mass function is same.
PMF is same, yeah. Got it.
Okay. So now it is very easy, right? To find fz of 3.
Only 2 cases are there.
So you have to find the probability for only 2.
Are we going with the grid method, sir, or not?
Which method?
Yeah, grid method. X, Y, 1, 2, 3, 4, 5, 6, it will be taking, and Y also, Y, 1, 2, 3, 4, 5, 6, it will be taking with
You
1
can
by
do,
6, 1 by 6.
you can do like that also. That the table method, right? But it's not
table
needed here, right? You can do it, but it will be like very hectic to prepare that table.
Everything is 1 by 6, so we can add 1 by 6 plus 1 by 6.
Yeah, you can actually find the probabilities for
Finding the joint probability is easier. So
yeah. So if you see, the solution will be the same. Shall we go to the solution?
Yes.
Okay.
Yes, sir.
So this step is first one is what we have done right now.
Right.
And this is same as this is joint density that is and if they are independent, that means I can write P of probability x equals to 1 comma y equals to 2 as probability that x equals to 1 into probability that y equals to 2, right? Similarly like this, probability that x equals to 2 into probability that y equals to 1. So this is there. Now if I written like this in this step, second step, so what is probability that x equals to 2? It's 1 by 6. What is probability that y equals to 1? It's 1 by 6. Similarly, I can write 1 by 6 and 1 by 6 here. And if you multiply and do the addition, you'll get 2 by 36, which is nothing but 1 by 18. So option B is correct option, right? Okay, so shall we move to the next question?
Sir, just a follow-up question to this, sir. This one.
Correct.
Say, for example, if my variables could not have been independent, right? Since they are independent, so simply we multiplied the marginal probability and we got the joint probability, right?
Yes.
If they could not have been independent, they could have been dependent. Then what could have been our approach, sir?
What if they are not independent, right? You're saying
they are dependent. So, for example,
then we cannot write this thing, right? In
Correct.
joint PMF, probability that x equals to 2 into probability.
Then what could have been our approach, sir? That conditional root or what?
Actually, see, we are not actually going into that details. But the thing is, if you don't have these things, then it will be very difficult to find the joint PMF itself, right?
Correct. So, for example, in exam we encounter that kind of question.
No, it won't come. Don't come.
Okay.
All will be related to IID samples only. Okay. Most of the problems will be from IID. It won't be like because dependent. If it is there, then you will get that table. That PMF table will be there, right? The probability table.
If they are dependent, then what would have been our what could be our approach? That conditional probability or what? Conditional probability into marginal probability.
Yeah, that you can do, yes. If it is not there, right? Okay.
You can notice.
So okay, now the same problem is there. This was this problem, right? Similar is there, only PMF has changed in this question 3. Understand, right? X is geometric P, Y geometric P. They both are independent, and both are geometric means they are discrete random variables, right? And we have to find z equals to x plus y. What will be fz of 10? So what you have to find here is, I'll tell you. So I wanted this answer from all of you to be correct as, see, my x is geometric P. So what is the range of x?
1 to
6.
Okay, and what is the range for y? Tx and ty are correct. Then my z is x plus y, right? So what is the range of z?
2 to infinity.
3.
From 2 to infinity.
Correct. So I wanted, what I wanted to find fz of 10, right? So what will be the, so what are the possible cases here? You have to find
so
out.
It is capital FZ or what?
I think we have to find. I think
it's CDF or what? No, it's
no,
PDF.
it's PDF. So PMF only.
Okay.
Sorry, where it is? Okay. So just find it out.
Sir, how will we type the answer?
Okay, so 24 responses I got until now out of 41. So okay, 2 more minutes and we'll discuss the solution. Shall we see the solution? So answers are B, D, B, C, B, C, C, B, okay, C, B, C, D, B, C. Variety of answers are there. Let's see what is the correct answer. Shall we go to the solution?
Yes.
Okay.
Yes, sir.
Yes, sir.
So we have to find a probability that Z equals to 10, right? So how can I write that Z? What is Z? Z is X plus Y, which is equals to 10. And the second line is, so what are the different possibilities that Z will take value 10 if my X and Y are geometric? So X is having range from 1 to 10 and Y is having range from 1 to 10. So if X is having 1 to 10, so if X is 1, then Y will be what?
9.
9.
9.
If X is 2, then Y will be
8.
like that, right? So until what X can take, like X will, if X is 9, then Y will be 1,
1.
right? So is it possible that X is 0 and Y equals to 10?
No.
No.
No. Why?
Because geometric progression. Because geometric progression.
Because of the geometric distribution. Because geometric distribution range starts from 1.
1.
So that's why here the summation is only from 1 to 9, right? Your I goes from 1 to 9. So when X is equals to 1, Y is equals to 10 minus 1, which is what? 9, right? So this step is clear. The second one. So this is a joint PMF, right, of X and Y, and you have to submit from 1 to 9, correct?
Yes.
Right. Now, if this step is correct, then you see this is the same step. It's written only the multiplication. And why this multiplication is happening here?
Independent.
Independent. Because both X and Y are independent to each other. So that's why we can multiply the probabilities, right? So what is the probability that X equals to I? If this is a geometric variable with parameter P.
P into 1 minus P to power I minus 1.
This is okay?
Yes, sir.
And what is the probability that Y equals to 10 minus I?
P into 1 minus P to power 10 minus 1 minus 1.
10 minus I minus 1. Right?
Minus 1.
Right? So this is okay? This step?
Yes.
Okay. So 1 minus.
Sir, what about the last bit? Again, like
Okay,
at the end also you
I'll
put
write.
3, right?
I'll write. So if I write here, it's okay, right? Sorry, so what you have to find Z equals to 10, right? So what is probability that z equals to 10? Okay. Then how can I write this? Probability that x plus y, it should be equal to 10. And when this will happen, so right, the step is okay, right? And since they are independent, if they are independent, then probability that x equals to I into probability that, and summation again goes from 1 to 9. This thing okay? This step is okay?
Yes.
Yes,
Yes,
sir.
sir.
Okay. So then if my variable, so for one variable, suppose x is geometric p, then for n trials, what is the probability? PMF or not n trial, when probability that x equals to, let's say, 5. What is the probability? How can we write the probability that x equals to 5?
1 minus p
To the power?
P into
4 into
4
p.
into
Right.
P.
So this is what 4 means 5 minus 1, right?
Correct.
So if I say I here, then what should I write here?
I minus 1.
I minus
I
1.
minus 1.
So this summation will be there, I equals to 1 to 9. It will be 1 minus p to the power I minus 1 into p. And suppose instead of I, if 10 minus I is there, then how can I write this one?
10 minus I minus 1.
10 minus I minus 1. Right. This is same here, for y equals to 10 minus I, because this is also a geometric variable with same parameter p, right? So I can write 1 minus p to the power 10 minus I minus 1 into what? P. Now p and p, it will become p square. And 1
Yes,
minus 1 minus p is same base, right? So what will happen here? I minus 1 plus 10 minus I
8.
minus 1. This I get cancelled. 10 minus 2 is 8. Right?
Okay. 10, like p square is okay. 1 minus p to the power I minus 1. Then 10 minus I minus 1. So I minus 1, that get cancelled. Only returns
minus 1 and minus 1 is there, right? 10 minus 2.
Yes.
Okay. Okay. So this is 1 minus p to the power 8. P square anyway, you can take it common. Like both of them you can take it common. And summation of I equals to 1 to 9. What will happen then? It is like 9 times, right? 9 times these terms.
Yes.
This is okay. Last step, did you understand last?
Yes, sir.
You're adding that expression 9 times.
Yes, adding this p square into 1 minus p to the power 8 9 times. That means same thing, right? Multiplying 9 times to these terms.
Yes.
Okay, shall we go ahead then?
So what option C not correct? Option C.
Option okay, which
C,
option?
C, yeah, this one. Option C.
Option B and
Okay.
C are correct.
Correct. Yes. Okay, thank you, sir. We can
Okay. Shall we go ahead? Same setup is there. Only the change is we have to find probability that z equals to 10 is less than probability that z equals to 9. And we have to find the value of small p for this condition to satisfy. So what you have to do is you have to find probability that z equals to 10. You have to find the probability that z equals to 9. And then you have to make the comparison. Okay. So you have already found out the probability for z equals to 10. Now find the probability for z equals to 9. And then compare. So you will have 5 more minutes to solve this.
Sir, can you show the last problem? Sir,
Options?
Yes, sir.
So this was the second step, right? Third step, I think, multiplication. This is also correct. And this is the final.
Yes.
That's why B and C are correct.
I have just entered C.
Okay. Shall you go?
Yes, sir.
Okay. Now, same thing you can do for probability of z equals to 9, right? And then you have to compare. It's like very easy question. Okay. Now, because you have already found out the probability for z equals to 10, you have to do the same thing for z equal to 9. And then you have to compare. So after 5 minutes, we'll discuss the solution. Okay, I got 22 responses here. Option C is the popular option, I think so. C. Okay.
Being inequality, it is a tricky one, sir. We doubt whether to cross that inequality or not in the examination or sometimes.
For z equals to 10 and z equals to 9. Hello?
9p square 1 minus p raised to 8 for z is equal to 10,
So
sir.
you guys have found out, right? Now,
Yeah.
how to deal with that inequalities? We'll see in the solution. So try to answer it first and we'll see. So take 1 more minute, then we'll discuss that solution.
9 is 8p square.
What happened?
I said z equal to 9 is 8p square 1 minus p to the power 7.
Okay, I don't know the answer, so we'll see.
While ago, you had shown the answer, sir.
Huh?
Yeah, a while ago, I think you shown the answer by flipping through the screens.
Okay.
I think we could see the answer. Yeah, that's it. See.
Option C, but we don't know, right? Say, let's say that might be a wrong answer. Who knows?
Could be.
We don't know.
Okay.
These are the only responses. So student which have done, right? We don't know whether this is correct or not. We'll see
All right. I'm on the wrong line.
Shall we proceed to the solution then?
Yeah.
Yes, sir.
Okay. So this is like same thing, right? For probability z equals to 9, it's only like now it becomes 8 times p square into 1 minus p to the power 7, right? 1 less, correct? Now we have to find this probability that z is equal to 10 is less than probability that z equals to 9. So you'll do like this, right? 9p square into 1 minus p to the power 8 less than 8p square into 1 minus p to the power 7. So this will get cut, right? 1 minus p to the power 7 and this 8. So here in this side we will left with 1 minus p. So 9 times 1 minus p, which is less than 8, which is only less than 8, right? Correct? Shall I write or is this okay? Is okay?
Yeah, it's okay, sir.
It's okay, right? Because yeah, nothing is there to actually same thing. I'll write there. It's okay, fine. So 1 minus p should be less than 8 by 9. So if 1 minus p is less than 8 by 9, then if p will go to that side, right? And 8 by 9 will come to this side. So what will happen? 1 minus 8 by 9 should be less than p. So that means p should be greater than 1 minus 8 by 9. So 1 minus 8 by 9 is what? 1 by 9. Okay. I think somebody has asked me, so why this is right? So this is our equation, correct? So generally, if you have like equality like this, 8 by 9, suppose, how will you write then? This term will come to this side, right? 1 minus 8 by 9 equal p. So same thing we are doing here. 1 minus, so 8 by 9 will come to this side is less than p. So it is like 1 by 9 less than p, or you can say p is greater than 1 by 9.
So I think that inequality is a bit tricky, sir. That's all.
Okay. So you actually you have to follow this whatever is asked, right? If you stick with these things, then I don't think it will be very difficult. If you go to here and there, try to do something else, then it will become a problem. Okay. So shall we go to the next question then?
Yes.
The answer C is correct answer. Okay, and it was a popular answer also. So okay, this is the 5th question. Okay, again the same thing. Z equals to x plus y. Okay, but here what is the change now? It is x and y are Bernoulli random with different parameter p. Right? It's now it's easy, right? What you have to do now? Can you tell me? First step. What will be the first step? Range of x. Yeah. So what is the range of x here?
0, 1.
0, 1. What is the range of y?
0, 1.
Right. 0, 1. Then what is the range of z?
0, 1, 2.
0, 1, 2. Right? Now what we have to find here?
Z1.
But the range of x and y are not clear, sir. Can you explain, please? It's Bernoulli, right? So Bernoulli will.
Bernoulli
Okay.
will take
Yeah,
0, right?
yeah. Okay. Yes, yes.
Okay.
Yes.
Now z equals to 1, so we have to find z equals to 1. When it will happen?
0, 1 and 1, 0.
0, 1 or 1, 0.
X is 0,
0,
y
1,
is
1,
1.
0.
X is 0, y is 1.
Yeah, so
Y
that
is
is
0, X
right.
is 1.
So that is the answer. We can calculate now. So only these steps you have to follow every time actually. If you see, the crucial part is
For Bernoulli, sir, what is the probability? Like, what formula we'll use? Will it be NP or?
It's a Bernoulli, right? What is the formula for Bernoulli?
One trial.
Axis and that is one is 0.4 for x and for 0 that is 0.6.
Okay, you think about it. It's not actually, it's very difficult thing, right? 0 and 1, 1 and 0. Find it out. We'll see the solution after some time. I'll take, I won't give you much time to this, right? I'll give you 3 minutes from here to solve it. Already 4 people have answered.
So just Bernoulli, like, what is the probability that we'll use? For 0, it would be 0.4, and for 1, it would be 0.6.
No. So for Bernoulli, this is the probability for success, right? So success is when? 1 for 1, right?
Yeah. So let me see the solution. So can we see the solution, please?
I got still 27. If you do hurry, then we'll move to the next question.
Sir, can we move to the solution, please?
Yeah.
Yeah.
Sir, can we see the solution of this, sir, please?
So as I said, there are only two possibilities, right? When x equals to 1 and y equals to 0, and when x equals to 0 and y equals to 1, correct? And x and y are independent random variables. So we can write probability that x equals to 1 into probability that y equals to 0 plus probability that x equals to 0 into probability that y equals to 1, right? What is probability that x equals to 1?
It is success 0.4.
0.4. And what is probability that y equals to 0?
0.8.
Right. Same with what is probability that x equals to 0? It's 0.6. And y equals to 1 is 0.2. So if you multiply these probabilities, you'll get this answer 0.44. And after adding this, right?
Yes.
Okay. Right? It's not difficult, right? This was very easy, right? Compared to previous ones. Okay.
Yes, sir.
That was same thing we are doing again and again, right?
Sir?
Yes.
Just to reconfirm one understanding,
Uh-huh.
here since their marginal probabilities are not same, so can we say that they are not IIDs, like they are independent but they are not identically distributed? Is it a valid statement?
So what is the condition for the
IID?
two be independent?
Yeah, so first of all, they have to be independent, one condition, and the second condition is their marginal probabilities have to be same, right?
Not same. The multiplication of the marginal probability should be equal to the joint probability, right?
So that is the condition for independence, right?
Yes.
I am saying for identically distributed, there are two conditions. Now for IIDs, there are two conditions. One is independence and the identically distributed, right?
Correct.
So for identically distributed, generally we say that marginal probabilities have to be same, right?
Yes, correct.
So
yes.
Here marginal probabilities are not same, hence these are not identically distributed. Can I say this statement? I'm just reconfirming my.
Yeah, this is not actually identically distributed, right?
Okay.
This is a separate random variable and y is a separate random variable, right? If x and y, if having the same parameter p, that is 0.4, suppose x is Bernoulli 0.4 and y is Bernoulli 0.4, and it is written that both are independent, then they are identically distributed, right?
And sir, in the follow-up question to that, sir, if my x and y are following different distribution, like one is following binomial and the other one is following geometric.
Correct.
And if we have been asked to find out the some function, then can we do?
And you are saying they are independent also, right?
Okay. Yeah, they are independent. So can we need to perform separate, separate treatment for them and then carry out the addition function? Separate treatment as in? Like, one is following binomial and the other one is following geometric distribution, right?
Okay. Okay.
And we have been given some function z equal to x plus y.
Okay. So okay. Suppose your x is let's say geometric.
Correct.
Okay, geometric with some parameter p, and y is?
Y is my binomial.
Okay, binomial
with some np.
np. Okay. This p is different. So I'll say p1. This is p2. Okay. Then z is
x plus y. So if this function is given, so then
they are independent, right?
Yes, they are independent. Then what should our approach, sir?
So suppose same approach. It's not like different one. Suppose I'll take some numbers, okay? Because sometimes numbers will be good to follow, right? So yes. Geometric probability, what let's say some 0.4, okay? Yes. And here is 6 and let's say 0.5, and z is x plus y. And what is the range for x? First of all,
for geometric range will be 1, starting from 1 to infinity, and for binomial it will be 0 to 6.
0 to 6, huh? Yeah.
0 to 6.
So what is the range for z?
Range will be 1 to 7. Sorry. 1 to 12.
Infinity, right? No?
No, sir. Up to 6 only. Okay. Yes.
This is the addition of.
Yes. Yeah.
And if I wanted to find the for probability of z equals to, let's say, what, 2.
Yes.
What should I do?
Then my cases will be 0 to 2011.
0 to
11
11 is 11 is there, yeah.
and 20.
20 is there. Any other case? No. Then so this is x, this is y, this is x, this is y, this is x, this is y. You know how to find the probabilities for, right? But for 0.
So x will be treated with respect to geometric formula and y will be treated as per the formula of binomial, right?
Correct. And you add this, right?
Yes.
Same procedure. So what is the important step you understand, right? This thing.
Yes.
Finding a range.
Yes. And my doubt was related to the final step, which you have clarified that x will be treated as per geometric distribution and y will be treated as binomial.
Correct.
And then
In the previous question, sir, you gave 0 to. So 0 would be considered as a failure or as a success will take.
Okay, one more thing is this is not possible, right? One more. This thing is not possible, no? 20.
Right?
20 is not. Sorry, 0 2 is not possible, right?
Yes, sir. That's right.
Yeah, because our geometry starts with 1.
Yeah, geometry starts with 1. Sorry, yes.
Only 2 conditions will be there.
My mistake, sir. I'm extremely sorry.
Okay, this should be correct. Okay, fine. Right. Shall we go to the next question then? So you understand, right? Any question, just find out the range. That is the most important thing here. If you find out the range, the other procedures will be the similar thing, right?
Sir, would you please solve the previous question, what that Mr. gave us?
No, this is solved, right? What is there? Like
Yeah,
you can.
I know, sir, but I understood till here, and I want to understand the final step. I want you to solve the whole problem.
Okay, so you can solve by yourself, right? See, okay, you tell me now. What is your name?
Vivek, sir.
Okay, Vivek. So if my x is equals to 1 and y is equals to 1, what is the probability for x equals to? So I can write like this: probability of x equals to 1 into probability that y equals to 1 plus here
probability of x is equal to 2 and probability of y is equal to 0.
So x is what? X is my geometric random variable. So what is the probability for x equals to 1?
X is equal to 1 means 0.4. 0.4.
Why? So this is 1 minus p to the power n minus 1 into p, right? So n is 1, then this is 0. So this becomes 1. This term will become only p will be there. 0.4 into what is probability of y equals to 1? 6c1 binomial, right?
Yes, NC1, NC1.
And what is the probability for x equals to 2?
1 minus p, yeah, to the power.
Correct?
Yes, sir.
This is the answer.
Yes, sir. Thank you so much, sir.
Okay. Shall we go next now?
Yes, sir.
Okay. Now this you have to find it out. This is like
Sir,
same.
The previous one, the geometric one, what did you write there? Can you please go back to that page, please?
This one, 0.6 into 0.4.
That 0.4, that formula, what did you write there?
Yeah. For what is the formula for geometric distribution? What is the like 1 minus
1 minus p to the power.
So when n is equals to 2.
Yes, sir. I got it. Got it, sir.
Okay.
Thank you, sir.
So this is you have to use the conditional probability. You have to find a conditional probability. So what you have to use is conditional what? Conditional probability formula, and then you have to find the answer. I'll give you 5 minutes for that, and then we'll go to the last question. Is it okay now?
Yes, sir.
What I have to confirm? I've tried to explain in this on my page. Which one? Regarding what, Nikhil?
Hello.
Yes,
Am I
Nikhil.
audible, sir?
Yes, you are audible.
Sir, there is a confusion between IIDs. IIDs, I have tried to explain in the previous chat. You have to scroll up. And that discussion was going on, and I wanted to confirm that from you.
What is IID? Is what?
So can you please explain the solution, sir? I'm traveling. I'll be disconnected. I won't be able to see the solution of this.
If you scroll up, sir.
Yeah, just Nikhil, wait. Then just we'll finish up the solution and then.
Okay.
Yes,
sir, okay. So shall we move to the solution? I think like a lot of people have given the answer. 25 has given the answer, and mostly it is B. Okay. Shall we see now? Okay, the correct answer is what? 0.73, which is B. Correct. So what you have to do is provide f of x given z equals to 1 of 1. What does this mean? Shall I write the solution or will this be okay? Okay, right?
We have to find a probability when x will be 1. Z is equal to.
So joint in the numerator it will be a joint density, that is probability that x equals to 1, right? And z equals to 1. And what is the denominator? Since it is a conditional probability, the denominator will be probability that z equals to 1, right? So in the previous problem itself, we have found out what is the probability of z equals to 1. What is that? When x equals to 1 and y equals to 0, plus when x equals to 0 and y equals to 1. So in this case, in the numerator, what is written here? Probability that x equals to 1, comma z equals to 1. When this will happen? Okay, I will write here. This is the important step. So
y equal to 0.
So we have to find f of what? X given z equals to 1 of 1, right? So that is nothing but probability that x equals to 1, comma z equals to 1. So how many of you have the confusion in this first step? Or do you have any confusion in this step? First step?
I have, sir. Sir, please explain.
Yeah. Tell me, what is the problem here? Do you understand what I have written here? Is a conditional probability. See, this is nothing but probability that x equals to 1 given that z equals to 1. So how you write the probability that x equals to 1 given that z equals to 1? We write it like this, right? Okay. Correct. About the denominator, since both of us like x and y are Bernoulli, right? With different parameters, obviously. So I will write it like it's okay. For now, it's fine. So I told you what is the range for x and what is the range for y. So what is the range for x? 0 and 1, right? This is the range for y also, 0 and 1. Now, to have z equals to x plus y, which is equals to 1, what are the different possibilities are there? So
0, 1, 1, 0.
Yeah. So when x equals to 0 and y equals to 1, or so okay, this multiplication why I write here? Because they are independent, right? Okay, great. So y equals to 0. So that is my denominator. Now what about my numerator? So I wanted to find the joint density when x equals to 1 and z equals to 1. So but what is z here?
X plus y.
So I can write like this.
Yes.
Instead of z, x plus y equals to 1. But given, so this is joint density, right? So when x takes value as 1, then what value should y take so that it will become 1?
0.
0, right? So can I write like this? This is same as that of this, right? This thing is same as that of this, right?
Sir, here I have a small doubt. Like when you are calculating for x is equal to 1, shall I not consider the 0th one also? 0, then plus 1, then total I should add up then.
1 minute. So how we write the joint densities? So we'll do like this, right?
Yes, sir.
So when 0, 0 is there, what is the probability, right? Some x, let's say. We can find it out, but for now I don't want to find. So it's like x, y. Let's say not x. Okay, some say this p is there, p is there, p1, p2, p3. So these are the probabilities. So if my z is equals to x plus y, and if I wanted to find the joint PMF for what? X and z. So when x is equals to 0, z can be equal to what? 0, right?
So because z is x plus y, so the time when x 0 and y becomes 1, that time z can be 1.
Yeah. So what is the range of z here? It's range
0,
of
1,
z
2.
0, 1, and 2. So and what is the range for x is 0 and 1.
0,
So when x is 0 and z is equal to 0, when this will happen?
Y becomes 0.
Y equals to 0, right? So
yes.
this z equals to 0 is nothing but the joint density when x equals to 0 and y equals to 0. Correct? Same probability will be there, right?
Yes.
You are understanding this point?
Yes, sir.
Okay. Similarly, when z equals to 1 will happen?
X becomes 1, y becomes 0, or x becomes 0, y becomes 1.
So when x is 0, which probability I should write in this this box? So this box will be having x equals to 0 and z equals to 1. So I'll write the probability when x takes value 0 and y takes value 1, right?
1. Yes.
Right. And this box when x equals to 0 and y equals to, sorry, x equals to 1 and y equals to 0. So you got it right now? You're understanding?
Yes.
So here when my x equals to 1 and z equals to 1 is there, then in that case what will happen? So this is nothing but this probability, right?
Yeah.
X equals to 1 and z equals to 1. So this is nothing but this probability. And what is this? This is this.
No.
There will be y is equal to 1 or y is equal to 0.
0, right? Because see, already if my x is equals to 1 and I wanted to be having z equals to 1, so when it will happen? Because z is nothing but x plus y, already my x is taking value as 1. My y should take value 0 only, right? Then I will get the sum as 1 here.
Yes, sir.
Still not getting? Okay.
I think in that box, just below 1.
Okay, no, okay, we'll try to find it out in a different way. So you guys just tell me. So you understand the ranges, everything, right? Now the problem is here. So tell me, provided that x equals to 1 and z equals to 1, I want to find the probability for this to happen. Okay. What is my z? Z is my x plus y. Can I write like this? Provided that x equals to 1, comma x plus y equals to 1. Okay, I can write like this. Okay. So can you tell me that when this will happen?
When y is equal to 0, sir.
No, only x plus y equals to 1 when this will happen. When?
Equal to, yeah, 0 plus 1 and 1 plus 0.
1 plus 0, yes.
Only two things are there, right? This is what we have written here. Okay. But for joint density, okay, for joint density, when my x is taking value 0 or when my x is taking value 1, then which of these two conditions I should take, or should I take both the conditions?
The second one.
Which one? This one, right?
Yeah.
Because if you put value of x1 here, then automatically my y should take value 0, right? Then only you will get the sum as 1. Correct?
Yes, sir.
So this is nothing but what? Probability of y only, right? Y taking value of 0.
Yeah.
That is what written here. No? Okay. Okay. Still will. Okay.
I
will
think. I mean, does anyone still not understand this one?
A lot of people are not understanding.
What?
Understood, sir.
Understood,
Yeah,
sir. I think we can.
Yeah.
You understood, right?
Yes, sir.
What I wanted to tell is when x will take value 1, right? And when y will take.
The person who had asked this question, he has to confirm. Otherwise, we can move, sir.
Yeah, I think he needs to confirm.
What I am thinking is nobody understood that, but I'm actually.
No, sir, we have understood, sir, actually.
Yeah, we just don't.
You explained in two methods. We are very happy.
Yeah.
Okay, I thought like.
Sir, there was your range of y was 0, 1, 2. That's why I was confusing.
Okay. Okay. No, actually, I thought. See, nobody was responding, so I thought. Okay.
Yeah.
No, sir, you explained in a very nice manner, actually.
And we were under the assumption that person is understanding. He is still involved in discussion.
Okay, so there was a confusion. Okay, what I thought is okay. How I don't know how to explain it again. So,
Yeah, that you explained it in the easiest possible way. So.
Yes, sir.
So shall we go next?
Yes,
The
seven
last
questions, sir.
last
Yes,
question.
sir.
Sir, actually, I have a doubt in practice assignment. So after finishing this, can you discuss that one?
Yes, yes. So I will finish it like today by 6:05 or something. Okay, I won't be like extending too much. So we'll take that one. Finish this question first, and then we'll take and I'll drop off.
Yes, sir. Thank you, sir.
So think about this. This is like kind of somewhat difficult. I'm not saying much difficult. If you go by range, right? I don't think it will be very difficult question. Just take 5 minutes. You can solve it. Okay? Okay, shall we proceed to the solution? Okay, I think, yeah, this is like kind of difficult question, so a lot of people not able to answer, right? So this is not actually difficult, just the PMF joint is still different only, right? The range of x and y is given here, and you have to do the same thing again for z equals to x plus y. So can you tell me what are the possible values z can take? What is the range of z?
Start from 2.
1k minus 2
to infinity, sir.
It will start from 2.
It will start from 2 to infinity, right?
Yes,
So
sir.
in 2, what is the value, like what is the probability for fz of 2?
1, 1.
So that means 1 upon what? 2 to the power?
2.
That's for 3? For 3?
1 upon 2 to the power 3.
So 1, 2 and 2, 1. Both will be there.
Yeah.
1, 2 and 2, 1 both will be there.
Then what is the probability then?
So 1 by 2 to the power 3 plus 1 by 2 to the power 3.
What does that mean?
1 by 2 into 2 to the power 3.
That means or else 2 upon
1
2
by
to the
2
power 3. 2 upon 2 to the
2
power 3.
upon 2 to the power 3.
Okay. For
Sir, repeat, sir.
so for z equals to 4.
1 3 x and 1 3 2 3 1.
So three possibilities are there, right?
3 by 2 power
3 by 2 to the power 4. For 5? For 5?
4 by 2 to the power 5.
For 6?
5 by 2 to the power 6.
For 10?
n
9
minus 1
by
by
2
2
to the
power
power 10.
Okay, when for k?
k minus
K
1 by
plus
2 power
1. No, sorry. K minus 1.
Divided by?
K minus
To the power of k.
Then what is the answer then?
Third.
option 3.
Then right? That is the solution.
Not getting, sir.
Not understand? Okay, fine. It's okay. We'll discuss. But I will try to explain in another way now. So my x and y are having ranges as what? 1, 2, 3 to infinity. Right? Same as the y. Then what is joint density for x and y? This is nothing but a probability, right? And what is z? Z is x plus y. So what is the range of z?
2 to infinity, yes.
2, 3, 4 to whatever infinity, right? So when z is equals to 2, right? What is the probability? What is the probability of z equals to 2? Sorry. So when this will occur, z equals to 2?
So 1 1.
X equal to 1 and y equal to 1.
Right. This is only possibility. So so when x equals to 1 and y equals to 1, what will be the probability of z equals to 2? If you put it here,
Yes, sir. 1 by 2.
it will be equals to 1 upon 2 to the power 2. Okay. When for z equals to 3,
2 1 1 2.
so here 2 1 and 1 2. So how can I write the probability here? 1 upon 2 to the power 3 plus 1 upon 2 to the power 3, which is nothing but 2 upon 2 to the power 3. For z equals to 4, what are the possible conditions are there?
1 3 3 1 2.
So how can I write the probability here? 1 upon 2 to the power 4 for this, plus for this 1 upon 2 to the power 4 plus this is nothing but 3 upon. Right. So like that. So if you see the thing, when z equals to 2, what is happening here? This is 2 minus 1, right? 2 minus 1 upon 2 to the power 2. When z equals to 3, what is happening here? 3 minus 2 in the numerator and in the denominator 2 to the power 3. So when z is equals to k, what will happen?
Minus 1
Upon
2 to the power k, sir.
So that should be my probability. So that is the answer. Option C. K minus 1 upon 2 to the power k. Done?
Yes, sir.
Understand?
Yes, sir.
Okay, guys. Then I think we have covered like a lot of things. But you understand, right? What is the how to approach any problem of such kind?
Yes, sir.
Yes, sir. Sir, if here it is given that max of x and y,
So okay, this what is this question? If instead of that, find z equals to max x comma y. Huh?
Yes, sir.
Okay, so you tried out and posted in the discourse.
Yes.
Okay. Okay.
Sir,
and everybody will solve
sir,
this question in the discourse.
Sir, only one activity question, sir, if time permits. 2.10 question number 2. Only one, sir.
Okay.
2.10 question number 2. Even you can explain me.
Practice assignment, I have a doubt, sir.
1 minute, 1 minute.
Yes.
We'll take. Don't worry, we'll have time.
Question
So
number
that
2.
question number
2. Yes.
So, okay. So which of the correct joint PMF is the given question, right? But is it dependent question? Separate one.
No, it is separate one, sir.
Okay. If
Yeah,
X is,
but you have to take values of G and H from the previous question, I think.
previous question, right?
But it is not
Yeah.
written, no? That we have to...
But there's no other way.
Okay.
Okay, maybe okay. So we have to mention it here, right?
Yeah, it is not written. So I was also getting confused.
Because I was also thinking like how to get the values. Okay, fine. So we will make the changes here. Okay. I'm sorry. Like we'll do the changes. I'll note it down and I'll make it change. Okay. This is what activity question.
So range I am able to identify, sir. Range is option number 2. Like option number 2, range G012 and H is 01. This I am able to identify.
Okay. Okay, then
the question number 2 I am not able to proceed.
Find the PMF right now from using this table, above table.
Okay.
You can find the PMF.
Okay, then I will solve it again.
Solve it and
Sir, just a very silly kind of question. In question number 1, the first line which is written over there. Okay, you carry on, sir. You carry on.
Sorry. No. Tell me.
Yeah, this line like x1, x2, x3, x4. We have to read this tilde sign. We have to read that is distributed jointly as, right? How we read this line? X1, x2, x3, x4.
You can write. Yeah, you can say that. Or
is distributed jointly as. You have to read like this or what? How to read?
Yes. You can actually refer to like that.
Okay.
It is distributed like this. It's kind of that. This is the distribution only, right?
Okay, sir, I will solve it again. Okay, thank you, sir.
Okay.
9th and 10th one, sir.
Sir, in the same activity, can you explain me the last question, please?
Yes, sir, please.
First of all,
week 3, sir. Week 3.
2 point. Yes, sir.
Week 3 will see later. Week 3 will see later. Week 2 will just ask.
Week 2.
Sir, in the same, this activity, the last one, before last, 4th one, sir.
See that the random variables x and y, which represent the number of people shopping malls 1 and 2. Okay, they follow by, so both are x and y are following Poisson distribution, right?
Yes, sir.
So for first city is 10 and for second city is 20. What is this 10 and 20? It's a parameter, right?
Yes, sir.
Lambda
1 and lambda 2.
Yes, sir.
And x and y are independent. Now
Yes.
z is total number of people visiting the shopping mall. So what is z? Z is x plus y.
Yes, sir.
Okay, then it's fine, right? Same thing.
So e raised to minus lambda into lambda power z divided by z factorial. Correct, right? So that is a formula we should use.
Yes.
Option 2 is correct here.
Sir, 5th question.
5th is same again, right? It's a conditional probability.
No, the next is the question he has asked on conditional, sir.
This one, right? 5th is, that's what I'm saying. It's not difficult, right?
No, the next fifth one, sorry, the fifth one.
Fifth one is also, if you see the, you can do it like, see, what do you have to find then? Y given z equals to 30. I think so is mentioned in week 0, right? Regarding this. So when, if you have two random variables, x and y with Poisson distribution, right? Or else you can think about like this, when y given z equals to 30, right?
Okay.
Why it is a binomial distribution is, what is z? Z is x plus y.
Yes, sir.
So that means, and given that z equals to 30, what is the value of y? So suppose, tell me if z equals to 30, right?
Yes, sir.
And the parameter for x is what? 10. So average number of people coming to visiting city 1 is 10 and for city 2 is 20. So
Yeah.
what is the so once you have z equals to 30, right? Then what is the
Yes.
probability that y you will choose this?
Y is 0, sir.
Y is 0? Z is equals to x plus y, right? I'm not going to show you the derivation. It is available in the lecture.
Yeah.
I wanted to tell you that how to approach this.
Yes.
So provided that y is given that z equals to 30. So I know that given that z is equals to 30, right? And I wanted to find a probability for how, that means how many people are going to what? City 2, right?
Yes,
X is
sir.
city 1 and y is city 2.
City 2. Yes, sir.
Right. So isn't it a so if you know that z equals to 30, I wanted to say that one person coming, right? So what are the options he's having? First person coming, either he'll go to city 1 or to go to the
city 2.
City 2, right? So
Yes, sir.
all of these 30 persons, they have how many choices?
2 choices.
2 choices. That is, either they can go to city 1 or they can go to
city 2.
What is the probability for going to city 1 and what is the probability for going to city 2? So x is Poisson distribution, right? With parameter 10 and y is also Poisson with 20. Right? That means 10 average number, like average on an average 10 people are going to city 1, right? And on an average 20 people are going to city 2. This is the probability for like this one person coming here going to city or going to city 1 is what? 10 out of 30, right? Okay.
Yes, sir. 10 out of 30.
Correct. Is this a probability? No? Okay. Can you say there are 10 people, on an average 10 people are going to, so what possible value I can take?
10 by 30. 20 by 30.
20.
20, right here. So what is the proportion? Like what proportion means what? Here it's probability, right? So one person coming randomly here will go to city 1 is what? Out of the 30 people. Out of the 30 people, if somebody is randomly coming and going to any one of the cities, right? As city 1 or city 2, what is how it can be distributed?
10 by 30 and 20 by 30.
So that binomial.
1:2.
It's not 1:2 actually. Okay. See, actually there is a derivation available, right? Can somebody else suggest it? It will take a lot of time. Okay, tell me how can we write this? Is this okay?
Sir? Yeah, my connection was lost. Sorry for that.
See this, what the thing is, if any person is coming, so Z is what? It is how many people are coming. You try to understand by physically. So see, find the conditional probability of y given that the total number of people visiting shopping malls in city 1 and city 2 are 30. Okay. So in that case, if you see, if there are 30 people coming, right? So in that 30 people, either, so every person going to that shopping mall, right?
Yes, sir.
They have 2 choices. Either they can go to the
city 1 or city 2.
So and how many people are there? N number of people are there, right?
Yes,
Suppose.
sir.
So this n number of people have two options. Either go to this one,
city 1 or city 2.
Right.
Yes, sir.
Now, sorry, where was? Okay. Just a minute. So they have this option either. So this is a binomial problem, right?
Yes, sir.
Okay. And what is the probability for that binomial distribution? That you have to find it out. So this is for y given z equals to 30. So for that 30 people, how many will go to the city 2? That depends on this parameter, 20 per hour.
Okay,
It is
sir.
20 divided
By
by 30.
30. Okay, okay.
And if it was x given z equals to 30, right? Then it
Yeah.
would have been binomial
Binomial 30
1 by 3.
1 by 3.
Yeah.
Okay.
Detailed derivation is there actually. I don't want to do it.
Sir has derived it, sir.
Yeah, that's what.
Option.
Okay. So we'll take this practice assignment question and then we'll finish it off. What was the question? Somebody asked me the question. Practice assignment.
Actually, it was a week 3, sir.
Week 3, yeah. Shall we discuss week 3 later because we have time?
Only one question. So last question actually. Last one.
Okay, an urn contains 10 balls numbered from 1 to 10. We remove 6 balls randomly and add up their numbers. Let x denote the sum of the numbers of the balls removed. Find the expected value of x. Yeah, correct.
So what can we do?
So x is what? The sum of numbers of
sum of numbers.
Right.
6 random.
So what can be the first of all, what is the range for x?
It's actually 1 plus 2 plus 3 plus 4 plus 5 plus 6 are combinations of many things.
For 6, right? For 6 things. So okay, maybe the solution is available here.
Answer is
okay. Answer. Solution is also there, but I don't know. It's not started. Okay. So what I want to tell you is, so there are what x can take is so all the sum for 6, right?
Yes. Any 6 balls.
Any 6 numbers from 1 to 10, right? So and on what is the probability assigned to that? What will be the probability for any 6?
Any 6, 10C6. I mean, 1 by 10C6. 1 by 10C6.
1 by 10C6.
Any of the combinations.
Any of the combinations.
Any
Correct.
like out of the 6 taken,
Correct.
I'll have 1 out of one combination. 1, 2, 3, 4, 5, 6 is one combination out of like I'll have 10C6. That's
Correct. Correct. That is the probability. So how
Nice.
we find the expected value of x there?
So I get it. And like probability into the
Right.
sum basically z. I mean,
Sum, right?
yes, sir.
So we'll try that.
Still like how to find the sum actually. That's what like I didn't like how to take every case. We should take every case as a like how to move on with it. That's what.
Okay, and non-contestant was removed numbered from 1 to 10. Remove 6 was randomly and somebody is talking. Let x denote the sum of the numbers of let x denote the sum of the numbers of the removed balls. Find the expected value of x. Okay. Try that. So sum of xi is what?
Xi.
X is the number of ith ball removed. Then x will take value as each of the ball removed, right?
Yes.
And what we have to find the expectation of x here, right?
Nice.
So how will you find it? So normal formula for us is to find the probability for each x into
probability of x.
X, right?
Into x, yeah.
What is the probability for x?
1 by 10 C6.
10. 1 by 10.
What is 10 C6?
$210.
What is?
210.
And what is x?
6.
So,
Any 6 balls.
1 by 10, sir, is the answer. 1 by 10.
What?
1 by 10 is the final answer.
How?
Huh?
How it will be 1 by 10?
So now we have to tell us the summation, right? 1 to 6. 1 to 6. So what will be that? 21.
Sorry.
So 21 divided into 10.
No, it won't be like that. Okay. See, because this xi, right?
Nice.
It is the sum is it will be a different combination. Sometimes you will pick 1, 2, 3, 7, 8, 9, right? Sometimes you will pick 1, 2, like that. So what you have to do is I need to think about it a little. Just a minute. Okay. We can do one thing. We can actually so my x is equals to what? X1 plus x2 is 3, x4. I can do like this, right?
Yes, sir.
This is this is how we have to solve. So each x1 is what? It can take 1, 2, 3, 4, 10, right?
Yes, sir.
And say similarly. So this is xi, right?
Yes, sir.
Then how can you find? Now this expectation of x is what? Expectation of x1 plus expectation of x2 plus expectation of x6, right? And each is same. It is 6 times expectation of x1. It is 6 into what is expectation of x1?
5.5.
It is having 1 by 10, right?
Right, so 1 by 10, so 1 by 10 into 8. 5.5.
What?
5.5.
5.5?
55 by 10, right?
So it is like this, right?
Yes, sir.
So 3, 5, 11, 33, right? This is how we have to solve.
So in order to multiply the product, so no probability needed. Yeah,
No, actually, see, this thing is you can't solve by that, right?
Yes, sir.
Because x is you can think about each ball as a different random variable, and each x1 is having what? How many different possibilities? 10.
10 possible.
And we are adding all the probabilities, right?
Yeah, got it, sir.
Correct?
Thanks.
Okay. I also like confused at this initially, but
Yes,
if you see for the first time, it will take time.
yes, sir.
This Friday, do we have session?
Friday?
Yes.
Can you check the calendar, please? I don't know.
It is not updated in calendar.
Okay, then today it will get updated. Okay, I will let you know.
No, I think it will not happen. What the man was saying that because of upcoming festival.
Okay, the fest is there. Yeah, this week we don't have. Right. Sorry.
So it will start on next Monday.
Correct. Sorry, this 3 weeks we don't have any session. Yeah. Okay.
Yes, sir.
Okay, guys. Bye.
Bye, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you guys for joining.